Hello and welcome to this explainer. I am absolutely thrilled you're here today because we are going to demystify the invisible logic behind the buildings we inhabit every single day. If you're a student of architecture, engineering, or honestly, just someone fascinated by how our built environment comes to life, you are in the exact right place. We're going to look closely at what it actually takes to plan a building properly. And spoiler alert, it's a rigorous process. It is way more complex than just dropping a few walls onto a page. So get ready, because we're hoping to completely change the way you look at every single room you walk into. Here is our roadmap for today. We'll be moving through 5 key areas: beyond the basic shelter, the environmental filter, grouping and circulation, comfort and livability, and finally, the integrated design approach. All right, let's jump right into Section 1, beyond the basic shelter, the meaning of a blueprint. Let's start things off by completely challenging the basic assumption that a building is merely a structural shelter from the rain and cold. When you're looking at an architectural drawing, it is so vital to ask yourself what a single, simple line actually represents in the real world. For students just starting out, it's really easy to view a drawing as just a geometry exercise on paper or lines on a computer screen. But honestly, that is a trap. We need to shift that entire mindset. You've got to treat your drawings as a tool to develop the power of imagination. That line isn't just graphite, and it's not just pixels. It represents a physical reality that will absolutely dictate how human beings live, work, and move. And that brings us to a foundational truth. As our source material brilliantly highlights, that single line carries immense weight. To quote directly, each and every line on a drawing is the result of numerous considerations, such as function, structure, comfort, economics, and aesthetics. You see, a fully integrated approach is required here. Sure, that line might define a wall, but exactly where that wall goes? Well, that depends on analyzing psychological requirements, the physical topography of the plot, the direction of the wind, and of course the owner's budget. Every single dimension is a highly calculated decision. Moving right along to Section 2, the environmental filter, outside forces. Okay, so we're going to explore how a building acts as environmental filter number 2, with our clothing being filter number 1, of course, against the forces of nature. Planners use vital tools like the sun path diagram you see here to study a concept called aspect. Notice how it explicitly maps the movement of the sun along with seasonal wind directions. The ultimate goal here is to make sure rooms are perfectly oriented to capture natural benefits. For instance, because different activities happen at different times of the day, a bedroom might be placed specifically to catch that early morning sunrise. In colder climates, that naturally warms the space up. Meanwhile, think about a kitchen. A kitchen needs to be located where the main working area gets ample light, but it also has to be positioned so that prevailing winds blow cooking odors away from the living areas, not right into them. Makes sense, right? Now, while aspect deals heavily with climate control and interacting with nature, we have to compare it to another crucial principle, which is prospect. Aspect is all about arranging rooms to maximize benefits from the sun and wind, creating that controllable comfort. Prospect, on the other hand, focuses purely on positioning your windows, doors, and balconies to capture the absolute best external views. It's about taking maximum visual advantage of your surroundings. Or, conversely, if there's a really undesirable view right next door, prospect is the principle that tells you to design a blank wall there, or maybe plant a landscape barrier to hide it. So simply put, aspect is how the building feels. Prospect is what the building sees.
That brings us to Section 3, grouping and circulation, navigating space.
Let's actually step inside a building now. Imagine you're walking through these actual floor plans of St. Ursula's School, which is located in the Sindhudurg district of Maharashtra. Notice how the classrooms are so tightly grouped together. Grouping basically means arranging rooms that have similar functions close to one another so the whole building operates smoothly. In an educational facility like this one, the basic unit is the classroom. Here, they're arranged along a main corridor to effectively manage a really heavy flow of students. Also a key detail here, this specific school is in an area that gets maximum rainfall. Because of that, proper enclosed grouping and connecting corridors are absolutely vital, just to keep the school functioning during a massive downpour.
Now, this flow of people we just mentioned, that builds into the broader concept of circulation, which simply means the movement from one space to another. It's divided into 2 main categories. First, you have horizontal circulation. This is movement across a single floor via your corridors, lobbies, and passages. Second, you have vertical circulation, which is movement between different floors using staircases, lifts, and ramps. And what's really fascinating, especially for you students to note, is the specific space allocation required. In a multi-story building, planning for vertical circulation alone requires about 8 to 10% of the total floor area. Seriously, that is a massive spatial commitment.
To really put that into perspective, take a look at this highly specific diagram. It illustrates vertical circulation in action, showing a cross-section of a staircase. Notice how every single step, landing, and clearance height is precisely calculated. This isn't just about casually getting up and down. It is fundamentally about safe and efficient exit discharge. During an emergency, a poorly planned staircase is a massive hazard. The architecture has to ensure proper exit access and passageways, and that requires incredibly rigorous attention to these exact dimensions.
Let's move to Section 4, Comfort and Livability, the micro details.
Next, we need to zoom in on the micro details. These are the things that transform a mathematically sound, beautifully grouped building into a truly livable environment. True livability requires a rigorous, step-by-step approach. Step 1. Sanitation. Now, in architectural planning, sanitation doesn't just mean plumbing and pipes, it critically includes providing natural light and good ventilation. Both of those are completely essential for general cleaning and maintaining a healthy environment. Step 2 is designing for thermal comfort. This means thinking deeply about the thickness of the walls, the actual fabric of the building, and the air conditioning needs. Step 3 is highly practical, planning specific furniture arrangements based entirely on the room's utility. You don't just draw an empty box, you absolutely must know exactly how many desks or beds go into that box, to ensure the dimensions actually work for the real people using it.
But here is the catch. While we obviously want maximum comfort, all of these features are heavily constrained by economy. Economy inhibits the freedom of an architect. You must discuss current costs with the client early on in the process. The real challenge is achieving a feeling of spaciousness while using the absolute minimum necessary dimensions. Practically, this means you might have to design simpler windows, maybe use standard plain tiles, and optimize the floor plan to remove any wasted corridor space. And you have to do all of that while ensuring the people inside still feel comfortable and happy. It is a very delicate balancing act.
And finally, Section 5, the integrated design approach, balancing the elements.
This is the moment where all these competing, multidisciplinary factors finally meet on the drafting table. To really summarize this complex process, look at how these elements interact. The architect has to synthesize environmental controls like aspect and prospect, which directly determine how the building is oriented on the plot and exactly where the windows are placed. At the exact same time, they are juggling functional planning, grouping, and circulation, which dictates which rooms are next to each other and how wide those corridors need to be. And overlying all of this is livability and economy, which forces the designer to establish the absolute minimum dimensions that still meet sanitation and ventilation needs without blowing up the budget. You have to be thinking about all of these principles simultaneously to produce a successful blueprint. So, as we wrap up this explainer, I want to leave you with a challenge. I challenge you to look at your surroundings a little differently from now on. You now know that a building is so much more than just a basic shelter. It's an incredibly complex, carefully calculated environment designed specifically for human performance. So the next time you walk into a room, whether it's a classroom, a kitchen, or an office, stop for a second and ask yourself, why is this wall exactly here? Where is the sun coming from right now? How did I circulate just to get to this specific spot? Keep observing, keep questioning, and I promise you'll start to see the invisible logic of planning all around you. Thank you so much for joining me on this deep dive into essential building planning.